Okay, so we're going to continue with linear functions here, only we're going to, instead of just starting with the linear function, what I want to do is I want to show you a couple techniques on how you can find the linear function if you only know a couple of pieces of information, okay? So let's say for the sake of argument that the only thing you know over here is you know the rate of change. So let's say that we know that the rate of change is -7. Okay, and let's say the other piece of information that you know is that one input-output combination. Okay, so let's say that you know that f of 4 is equal to, I don't know, let's say f of 4 is equal to negative 5. Okay. And here's what that means. That means that when the x value equals 4, don't mix this up, because I know you're thinking that the y value is over here. Well, remember, this represents the y value, so that means y equals -5. So this is the same thing as writing y equals -5. Okay. And what normally goes inside the parenthesis here is an x. And so in this particular case, x is equal to 4. And so what this is saying is that when x is equal to 4, y is equal to -5. Okay? Now that's important. So here's what we're going to do. We are going to set up our linear function. We know, so if we said f of x is equal to, now we know right here is normally the rate of change, which is -7. So we're going to put -7 where the rate of change goes. We know that we always put an x after that. Now what we don't know is we don't know what the constant term is. So what we would do here is we would just write plus c, okay? You could also write plus b, but we're going to use the letter c for constant, okay? And so now, here's what we're going to do. The next step, once you set this up, okay, what we're going to do is we're going to plug in f of x. We're going to call this y, okay? And we know that y up here is equal to -5. So what we're going to do is we're going to put a parenthesis with a -5, because we know that f of 4 is equal to -5. So we're going to put a -5 over here. And we also know that x is equal to 4. So we're going to write -7, and in place of this x, we're going to put a 4. And then we're going to write plus c. And now notice, now that we have plugged all that in, we now have an equation with only one variable, and the variable is c. And so the next thing we're going to do is solve for c. And the way we're going to solve for c is we're going to take our -5 here, equals -7 times 4, that's -28. Plus c, and now we just solve. We're going to put plus 28, cancel, and so c is now equal to -5 plus 28 is 23, and now we have our constant term, which is now 23, which is our f of 0, okay? And so now we can write it as f of x equals -7x plus 23, okay? And now this is our linear function. Now we can take that linear function and we can identify the roots, we can identify the sign chart, we can identify the intervals of increase or decrease, but we know it's an interval of decrease because the rate of change is negative. The domain we know is -∞, +∞. Range is -∞, +∞. Because the rate of change is negative, we know that as x approaches -∞, f of x is approaching +∞, and the opposite down here, okay? And so this is how you can find all this information if all you know. So if you don't have the linear function, but you do know the rate of change, and you have one input and output value, okay? I think we should do at least one more example of this, and then you should practice it a lot with the worksheet that I send out. All right, so let's say that the rate of change is m equals 2/3. Well, no, you know what? Let's go with, how about 3 over 2 instead of 2 over 3. M is 3 over 2. And let's say that we know that f of negative 2 is equal to 5. Say that we know that f of negative 2 is equal to 5. So now what you may want to do is pause the video and see if you can figure that, do it the same way we just did it. Something else you could do is you could take this information, you can pause the video, maybe rewind the video and watch through the example that I just did and do it with these numbers with that procedure, okay? All right, so we know that we want to set up the linear function. So we're just going to say f of x is equal to, we have the rate of change, 3 over 2, so we're going to put 3 over 2, and then we're going to put an x right next to it because that's how the linear function always looks. Now the only thing we don't know in this is the constant term, so we're just going to put a plus c. And now what we're going to do is we're going to replace the y value, f of x, y, with what it's equal to, 5, right? See, look, f of something is equal to 5. The y value is 5. So we're going to put a 5 over here. So put a 5 equals 3 over 2. We know from looking at this that right there, that negative 2, that is the x. So in place of this x, we're going to put a negative 2. And then we're going to put plus c. Then we're going to solve for c. So 5 is equal to 3 times negative 2 is negative 6 over 2. So 3 times negative 2. And negative 6 over 2, well, that's negative 3 plus c. So we're going to say 5 is equal to negative 3 plus c. And we're going to add 3 to both sides. And we get c is equal to 8. So the constant is 8. That means that f of 0 is equal to 8. We can then write it as f of x equals 3 over 2x plus 8. And now we can identify the roots by setting this equal to 0. 3 over 2x plus 8 equals 0. Minus 8 on both sides. We get 3 over 2x equals negative 8. Multiply by 2. 3x equals negative 16. Divide by 3. X is equal to negative 16 over 3. And so our root is x equals negative 16 over 3. We can make our sign chart. Infinity, negative infinity. Put our hash mark. Put negative 16 over 3. Plug in something. Let's do it this direction. This is a negative number, so I know all the positive numbers are over here. So if I just plug in something positive like 3 or 4, I'm going to plug in 4 over here. So 3 over 2 times 4 plus 8. Well, 3 times 4 is 12. 12 divided by 2 is 6. 6 plus 8 is 14. That's a positive number, so I'm going to put a plus here. If this side's positive, this side's negative. Since the rate of change is positive, I know that we have an interval of increase, which is negative infinity to positive infinity. The domain, negative infinity to positive infinity, like it is for all linears. Range, negative infinity, positive infinity, like it is for all linears. And now the limit of f of x as x approaches negative infinity. As we go backwards, here's negative infinity, and look, there's a negative right there, so that must be negative infinity. The limit of f of x as x approaches positive infinity, look, there's a positive right next to the positive infinity, so that must be positive infinity, and we have identified all of our characteristics. Okay. All right, now we're gonna transition into another way of finding the linear function if we don't know the rate of change. All right, now suppose you have a situation where you don't know the rate of change. Also, you don't have the linear function. Well, linear functions actually have a really neat feature that all you really need are two input-output combinations, and you can find everything that you need to know. So let's say that we knew that f of negative 3 was equal to, I don't know, 7. And let's say we also knew that f of 4 was equal to, oh goodness me, how about 21? There we go. Now let's try that. See how that works out. Might be a disaster, but we'll find out. So let's say that this is all we know. about a particular function, that we know that f of x is a function, and that if you were to plug -3 in for, remember, that's an x, okay? The thing inside the parentheses, that's an x. This thing over here on the outside, that is a y value, okay? Don't mix that up, okay? So if all you knew that f of -3 is equal to 7, and that f of 4 is equal to 21, well, this is actually enough information to be able to find the rate of change. Then once you know the rate of change, you can do what we did, what we just did previously, and you can then identify the constant term, and then you'll have the function itself. So let's go ahead and do that. We know that the rate of change, m, is equal to f of some x value minus f of another x value divided by the first x value minus the second x value. So all we have to do is take our information up here, our x's and our y's, and plug them into here, okay? And so remember we had said previously that b is typically a larger value than a, that a is usually the smaller x value and b is usually the larger x value. Well, let's look at the x values we're dealing with. We're dealing with a -3 and we're dealing with a +4. So why don't we say that -3, we'll say that a is equal to -3, and we'll say that b is equal to -4, okay? And so what our formula is now going to become is, it's going to be f of whatever b is, or not -4, that's +4. Sorry, folks. It's a +4. b is equal to +4. Okay. See, +4, +4. Sorry about that. So our b is +4, so here f of b is f of 4 minus f of a is -3, so that's f of -3, all over b, that's 4, minus, and a is -3. So now that we have this formula, we can go one more step because we know what f of 4 is. F of 4 is 21. So we're going to put in place of f of 4, we're going to put 21 minus f of -3 is 7. So we're going to put a 7 here over 4 minus -3. Well, 4 minus -3 is the same thing as 4 plus 3. So that means in the bottom here, we're going to have a 7, okay? And now 21 minus 7, that's 14, divided by 7, and that's equal to 2. And so what we see here is just with these two pieces of information, we were able to find that our rate of change for this linear function is 2. And so our rate of change is 2. Now that we know that our rate of change is 2, we can implement what we just learned a few minutes ago, where we take a rate of change and a single point. Well, you might say, well, we don't have a point, Mr. Ryan. We have our rate of change now. Well, remember, in the original problem, we were given 2 points. So you can actually pick either one of these. You can do what we did where you have the rate of change and you can use this point, or you can use the rate of change and do this point. Now, I prefer working with positive values, so I'm going to use this f of 4 equals 21. So what I'm going to do is I'm going to set up my linear function. We know that f of x is going to be equal to the rate of change, 2, times x, and then plus c, the constant that we don't know about, the constant term, okay? That's what we're going to try and solve for. Well, we know that over here, we're going to use this one, so we know our x is going to be equal to 4, so equals 2 times 4 plus c, and f of 4 is equal to 21, so we're going to put our y value here, 21. And so now we have 21 is equal to 2 times 4 is 8 plus c. Now we're going to subtract 8 from both sides. And we get 13 is equal to c. So now we know our constant term is 13. That means that our f of 0 is also 13. And now that we have that, we can identify our linear function, which is f of x is equal to 2x plus 13. And then with that information, we can identify the roots, we can make the sign chart, we can identify the interval of increase or decrease, et cetera, et cetera, et cetera. Okay? Let's try another example. All right, so here's another example. We have f of 2 is equal to -6, and f of 17 is equal to 6. Why don't you pause the video and see if you can figure this one out, and then I will work on it and see if you got the same thing I got, okay? All right, so we know we want to find the rate of change. So let's erase this last example here. And we know that the formula for the rate of change is m is equal to f of b minus f of a over b minus a. And b and a are x values. We know our x values are 2 and 17. We'll make the smaller one the a, and we'll make the larger one the b, okay? And so now we're going to just fill in b, the two b's here with a 17 and the two a's with a 2. So we'll have f of 17 minus f of 2 over 17 minus 2. Well, f of 17 is given to us right here. That's 6. So we have 6 minus f of 2 is negative 6. So I'll put in parentheses, oops, that's not 16, that's 6. Negative 6 over 17 minus 2, okay? And now we know that 6 minus negative 6. So minus negative 6 means plus 6. So 6 plus 6 is 12. And 17 minus 2, that's 15. And so what's 12 over 15? Now, I know what you want to do. And I guess you can do m equals 12 over 15. But with linear functions, we need to reduce, okay? And so we need to find, is there a number that divides into 12 and 15? There is a number that divides into 12 that also divides into 15, and that is the number 3. So 12 divided by 3, that's 4. 15 divided by 3, that's 5. And so our rate of change is actually 4/5. And so over here, we'll say m is equal to 4 over 5. Now, we want to find the function. So we'll do f of x is equal to 4/5 x plus c. And then we're going to fill in, we got to pick one of these two. I think let's go ahead, I really don't want to work with 17. I don't want to put a 17 here, but I don't mind putting a 2 there, okay? So I'm going to use f of x is negative 6, so I'll put negative 6 in for y. Then I'll do 4/5, and then I'll put a 2 in for x, and then plus c. And now 2 times 4/5 is, really it's 2 times 4, it's 8 over 5. So we have 8 over 5 plus c. And then over here we have negative 6. And now, to solve for c, we're going to subtract 8/5. Subtract 8/5. Now this can be a little weird. What we have now is we have c is equal to negative 6 minus 8/5. Now this 6 is going to have to turn into a fraction over 5, okay? Well, 6 is the same thing as 30 over 5. So what we can say is negative 30 over 5 minus 8 over 5. And now we're going to do negative 30 minus 8. That's negative 38. And it's over 5. And so our constant term is negative 38 over 5. So we're going to do negative 38 over 5. And that also means that f of 0 is negative 38 over 5. And our function is now f of x is equal to 4/5 x minus 38 over 5. Now this can actually be simplified into 4x minus 38 over 5. Okay? Both of these are equivalent terms. And then, or expressions. And then what you can do is you can use that information, of course, to find your roots, your sign chart, your intervals, your domain, and everything like that. Okay? All right, so I think we're done with linear functions, and we're going to be moving on in the next lesson into quadratic functions.